Today, we're talking about relays. Buckle up. This is a relay. All by itself. A little boring, nothing exciting. This is just what they look like. This is also a relay. Different shape, different color, same function. They come in different shapes and sizes. Let me show you. These are all relays. These are all relay modules. This is what a relay looks like when it's attached to a board that controls what it does. But the real question is, what is a relay? What does it do? Well, a relay is a switch. It's basically an electric switch. So instead of your finger pushing a button and causing something to happen, electricity shoots through this and turns a switch on or off. It's got a mechanism inside that swings from one side to the other and makes contact with the mechanisms on the inside and turns something on or turns something off. And as I said, all of these do different things. These guys here are just 8 gang. They are 8 in a convenient package instead of having to wire them separately. See how these guys are all separate here? These are all just together like this. And you've got a 4 gang here. These are single ones. These are solid state. This is a timer relay. Actually, a lot of these are timer relays. Timer relay, timer relay, timer relay. Technically, these are not relays. They just function like a relay, and I'll talk a little bit more about that later. Some of these are triggered by 12 volts, and some of these are triggered by 5 volts. And I'll tell you exactly how to recognize that and how to wire these up to do many different nifty things. All right, so let's say this is your relay here. Most relays have 3 terminals here. You have your common, which is, we'll use as a C. Actually, for you guys, it would be this way. And you have your normally open and your normally closed. And as we talked about before, normally closed is when your switch is touching and it's causing electricity to flow through. And normally open is when the switch is open. All right, so that's all you need to know. The other ones here, depending on which kind you get, you've got your positive, negative, and your signal or in. It will also be say in sometimes. Sometimes they'll just say weird stuff. Sometimes they'll have Chinese writing on them. Sometimes you have to experiment and figure it out. So I will tell you the ones that I like personally later that are out there on the market right now. And then you've got your relay here with a bunch of other stuff around it, usually diodes and some other things, resistors and things to help keep down the electromagnetic interference that relays shoot out, which is one of the reasons I like to use relay modules and not just these by themselves, because all the work has been done for you. If you're the kind of person who likes to make your own stuff and wants to use one of these, go for it. It's all on you. But for those of us who just want to have an idea and just want to get it done, this is kind of what we're going over with the modules and stuff. On this little blue box, it will tell you how much amperage it can take and also what trigger voltage is. So let's say this is a 12 volt relay here, 12 VDC, voltage DC, all right? And you're going to run your positive and negative into the board. And I'll tell you the one thing that confused me first early on when messing with these is the relay has to be powered separately from the thing you were powering. So that is something you need to be aware of. And that was something that confused me as well. So let me kind of draw this out for you. You're going to have your positive running to power, and you're going to have your negative running to power. Let's say this is your power here, like that, positive, negative. And we'll talk about the signal in a second. So then let's say you have the thing that you're powering over here. This is LED or something like that, all right? Now, the nice thing about this is this can be powered by 12 volts here, like this. But this thing over here can be any other voltage you want. This could be 3 volts, it can be 24 volts, it can even be 110. This can do AC. Most relays can handle AC voltage, and it'll tell you what it can handle. Usually it's 110 or up to 250, some of them at 10 amps. So just make sure you understand all that before messing with it. But in this case, 12 volts is a safe bet, so we're just going to assume this is a 12 volt LED. And this is also going to be running to power. Here's your power here. Here's your negative. Here's your positive. Now, if you're in our previous video about how electricity is a circle, I talked about how you want to interrupt the positive line with your switch. This is just a switch. It's just a more complicated switch. It technically has 2 circles. It has this circle here, this circle here. It's got a bunch of circles on the board, but you're not making that, so you don't have to worry about it. So you've got your negative running to here, and now your positive is going to be interrupted here. You're going to run, C is for common, not cookie. I mean, it is other times, but don't worry about it. You don't have to worry about it. Common is the common line if you're doing multiple things, right? But in this case, you don't have to worry about it. You need one wire running to the common like this, and then your other wire running to this. This is acting as your switch right here. So this is normally closed that I wrote here. If this was on, these contacts on the inside are touching, right? I talked about earlier how this basically is a little mechanism that's doing this, right? So sometimes you'll see illustrations like this, and what this means is this is, let's say this is your common right here, and this is your NC like this, all right? This is what's going on. This means these are touching, which means it's closed. This is what's happening. And sometimes, as I said, you'll see this diagram in place of this, all right? So common here, common here. So what's going to happen is when power is applied, when power is turned on when power is turned on here, this little arm is going to flip. So it's going to go from normally closed, and it's going to flip over to here, to this side, to the normally open side, which then tells this to turn on. This is how you can have two things going on with a relay. You can have something that is lit up, and then in this case, and then when this flips over to here, this would go off, and another light would turn on. All right, so that's kind of what's happening here. So in this case, if you wanted this to be off, this would be running to here, like that. So that would be normally open, which means this light is off. And then this arm would flip over, boom, to here, and the light would light up. That's essentially, now how does it trigger? Well, I'll tell you. Usually you need a high or low trigger, and high means it's looking for voltage. It's sitting at 0, and high means it's looking for a trigger voltage. And if it's a low trigger, it's sitting at a high voltage and looking for a low. So you don't necessarily have to remember all that. You just need to know that if it's a low trigger, you have this signal wire. Let's say this is your button here. Let's say this is a button right here that you're going to push. And let's say this is a low trigger. All right. Low trigger. All right. Let me just close that. So it's a low trigger. You're going to run one wire to the negative. It's going to share this port. You're going to plug both of these in here like this. And now this is going to go into your signal. So now when you push down on this, it tells this thing to turn on, to do its little flippy arm thing here, and boom, magic. So how does this look like in practical application? Well, I will show you. I have my little 12-volt LED here, and then here's a 12-volt power supply source. Now I'm going to turn this on, and you'll notice nothing happened because the positive wire is running into the NO and out of the C. So nothing is happening because this has not been activated yet. That's why nothing has occurred. Now I'm going to plug this in here to the 12 volts, because it's a 12-volt relay. Now, I'll tell you, these are the ones I like. These new ones, these are fairly new in the last few years. They have a jumper here, this little jumper, and it has an L and an H. So if I pull this jumper off and I put it here, it's now looking for a high trigger, right? But if I usually like to do low, I don't know why, I just like a low trigger. But sometimes if something's not working right, check your trigger settings. So anyway, this is on a low setting. Here's my jumper wire right here. So we're just going to pretend that this is hooked to a button right now. And I'm going to touch this screw, which is the low, which is the ground. And when I do that, you'll hear a click, and it'll cause this to turn this on. Ready? Here we go. Boom. Just like that. That is how that works. And you hear that click. I'm going to get this close to the microphone so you can hear it. That is one of the downsides many people have to relays, is they can be very audible, especially when you're dealing with RFIDs. And that is something we'll go over in a different video. But right now, all you need to know is that this is 12 volts. I've got 12 volts running into it, and I've also got it set for low. Now, if it's set for high, I'm going to jump the jumper over here, put the jumper over here. Now, if I touch the negative, nothing happens because it's looking for a high signal. If I touch the positive, it works. So that's what that means right there. And these little breadboard guys with jumpers are actually really handy to have. They have these screw terminals here. Some of them don't have the screw terminals. Some have pins, and you have to solder and you have to plug stuff in. I highly recommend these with the screw terminals because it's just way easier to deal with. And you can find these online all over the place, different companies. So that is the basics of how this works. And again, if I was to have this with a switch, this would be wired into my signal or in, right here, and then this would be wired in with the negative like this. Actually, I can just kind of do this. I can touch these two wires like that. So now I'm just touching this with the screw terminals. And when I push the button, it happens like that. So that is how it looks in practice. The last thing I want to talk about is something you're probably going to encounter a lot when working with escape room puzzles, and that is triggering the relay by making it power on instead of triggering it through the signal and the ground, right? And so let me give you an example of this here. So let's say you're using a controller here, right? This is your Arduino, your Fright Prop, your Badass controller, whatever the heck this is, right? And then you have your relay here, like this. Here's your little relay guy. Here's your positive, your negative, and your signal. And then let's say you have a maglock attached to it, right? So there's your maglock right there. Maglock, all right? Here's the power for your maglock. This is your negative, negative, positive, positive, like that. So as we said before, your negatives are going to run into each other like that. And of course, here is your common and your normally closed. I'm doing that backwards, sorry. Sometimes I get confused. Let's see, the normally closed. There we go. So you're going to, of course, run your voltage like this. Nothing about this is any different than normal, okay? So now your maglock is engaged because the wires are connecting through common and normally closed. The one thing you're going to do over here, though, that's a little different, is you're going to take a jumper wire, just any type of wire, and you're going to run it from signal to ground, just like this. You're just going to screw a wire that is jumping from here to here. It's called a jumper wire because it jumps. Anyway, so now you run your positive wire to your controller and your negative wire to your controller like this. So let's say this is a 12-volt relay here, like this. And of course, your controller is popping out 12 volts as well, like this. So what's going to happen is this relay is getting no power right now. It is off, right? However, when it gets power, what's going to happen is because of this jumper, it's telling this thing as soon as it powers on to trigger like that, right? So that means that your maglock will then instantly disengage and the plate will fall off, okay? Or open, the door will open or whatever like that, okay? There are relays that are sold on the, I know Fright Props has them, that don't have a signal or in. It is just positive negative because those are specifically made to work with controllers like this to just turn on and do their thing. So basically it just cuts out the middleman, the middle jumper, whatever, by just powering this and doing its thing and turning on immediately. And you'll find different situations for this and different reasons to do it. Sometimes this just can't be powered for one reason or another, and sometimes you have this hooked up instead of a controller. You have an array of multiple other relays that then power this to do something over here. It can be a little cumbersome, but sometimes it is a necessary evil. So be aware that this is an option of something you can do when working with relays in escape rooms. There's a lot more to this subject, so we're going to roll this over into a second video, and we're going to go into more in-depth wiring and some other information about these kinds of relays. So stay tuned for Relays Part 2. Whee!